LeetCode Problem 9, Palindrome number. Hey everyone, this is Keystrokes. Welcome back to the channel. After our last medium level problem, it's time we tackle an easy problem. So today we'll be taking a look at LeetCode's problem number 9, which is called Palindrome number and has easy difficulty. So this is the problem statement. Here it says, we are given an integer x and we need to return true if x is a palindrome integer. Now what does palindrome integer mean? An integer is a palindrome when it reads the same backwards as forward. So here we can see it's 1, 2, 1, and if you reverse it, it still reads 1, 2, 1. Whereas for the example 1, 2, 3, if you reverse this, it will be 3, 2, 1, which is not the same. Example 1 talks about 1, 2, 1 that we just saw. If you look at example 2, here we have a negative number. Now when you reverse this, they say it becomes 1, 2, 1 negative, which is not a palindrome clearly. I don't even know what this is. Then we have example 3, where input is 10, and reversing this makes it 0, 1. And again, this is not a palindrome as it's not equal to the input. They also talk about the constraints, which shouldn't really affect us much. And then they also ask for a follow-up question, if you can solve it without converting the integer to a string. And that's what we'll focus on actually. So let's take a look at everything you need to know to solve this problem. And you won't believe it, the only thing you need here are loops. Okay, so let's see how we can solve this. But before that, don't forget to hit subscribe and like this video if all these LeetCode problems and solutions help you out. Okay, so let's take a look at an example. So an example on LeetCode was 1, 2, 1. So let's see how we can reverse this number. So first step should be to mod this number by 10. And that should give us the remainder as 1, which is the last digit. Now we can initialize a new variable, let's say reverse. And we assign the value to reverse as 0. Now we take the last digit that we expected, which is 1, and we basically want to append 1 to end of reverse. That is, we want something like 0 and then 1, which actually is just 1. But let's say if reverse was 23. Now how do we append a new number right here? Well, to do that, we can simply do 23 times 10 and then add the number that we want to append. So let's say in this case, if we wanted to append 1, we would do 23 times 10 plus 1. That will give us 230 plus 1, which gives us 231. And we can see 1 got appended towards the end. And that's what we are going to do to append the last digit that we extracted to this reverse number right here. So this will basically do 0 times 10 plus 1, which gives us 0 plus 1, which gives us 1. So this was first step, this was second step, and then we have a third step where we'll reduce our original number and strip off the last digit. And we can simply do that by doing 121 divided by 10, which will give us 12. Now 12 becomes our new number that we are operating on. So this is our step 3. Okay, so now let's do step 1 on number 12. So 12 modulus 10, this gives us 2. Now doing our step 2, we do 1 from here times 10 plus number 2, which comes from here. And this gives us 10 plus 2, which is 12. So now doing step 3, we have 12. Now we do 12 divided by 10, which gives us 1. Now doing everything again. So step 1, that's 1 mod 10. 1 comes from here. This gives us 1. Then doing step 2, which is 12 times 10 plus this 1, which gives us 120 plus 1, which is 121. So now taking this 1 and executing step 3 on it, I'm running out of space, so I'll write it right here, which is 1 divided by 10, which gives us 0. And once we get 0, this is where we stop executing our steps because we have nothing else to process. Now we can see the final number that we got on bottom right equals our original number that we started with on the top left. So that means this number is a palindrome. So let's take a look at another example. Let's say the number was 1, 3, 4, and 5. So in this case, we first mod it by 10, which gives us 5. This was step 1. Then we have our reverse initialized here to 0. So to this we do 0 times 10 plus this 5 that we have. So this will give us 5. Now executing step 3, which is 1, 3, 4, 5 from here and divided by 10, which gives us 1, 3, 4. So this was the first round. Now executing the second round. So step 1, 134 modulus 10, that gives us 4. This 134 came from here. Then we do 5 times 10 plus 4. 4 comes from here, and the 5 was coming from here, and this will give us 54. Then doing a third step, which is 134 divided by 10, which gives us 13. This was round 2. Now continuing on, 13 mod 10, which is our first step, which gives us the remainder as 3. 13 came from here. And then on our reverse, we do 54 times 10 plus 3, which gives us 543. 54 coming from here, and the 3 coming from here. Okay, and then our third step, which is 13 divided by 10, which gives us 1. Now this step is done. Now going to next round, we take 1, we mod it by 10, gives us 1. Then we do 543, which is coming from here, times 10 plus 1, which gives us 5, 4, 3, 1. And then our third step, to divide 1 by 10, which gives us 0. And because we got our 0, we can stop our rounds right here. And we can see 5431 is reverse of 1345, but they're not the same. So 1345 is not a palindrome. Now I want to discuss just one last thing on this, which is an optimization and some of the corner cases. So the first one is that 0 is a palindrome, which makes sense because reversing 0 is still 0. But any other number which ends in 0 cannot be a palindrome until it's prefixed with 0 as well. So let's take an example, like the number 210. In this case, if we reverse this, our number would be 0, 1, 2, which effectively is 1, 2. And 1, 2 is not equal to 210, so they're not palindrome. So for any number which ends in 0 to be a palindrome, its first digit needs to be 0 as well. And the only number that satisfies this is the number 0. So that is a very simple corner case that we can add. Now one final corner case are negative numbers. So let's say minus 212. This is not a palindrome because when we reverse this, it becomes 212 minus, at least based on example, that's where they put the negative sign. And this is not a palindrome. Okay, so let's take a look at the summary of the solution that we just discussed. So we are basically reversing the number and comparing it with the original. And to reverse the number, we'll extract the last digit of the input number by doing a mod operation with 10, which will basically give you the remainder. And then we'll append this last digit that we extracted to the reverse number that we are building. And then after we have built our reverse number, we just compare it with the input, and that's when we know if it's a palindrome or not. Okay, so let's code this out. Okay, so here I have IntelliJ with the same solution class, and the member method is palindrome, which takes in an integer x, as we see in LeetCode right here. I also have a main class which has an example test case, and it calls the solution class and the isPalindrome function in there. So before we jump into the solution that we discussed, I want to cover the string-based solution as well. And that's a very simple solution. So let's see how that will work. So first step is to convert this x into a string. So to do that, we can do integer to string x. And because we need to reverse this, we should use string builder for it. So assigning this to string builder and assigning this to a variable, let's say string builder, original number builder. And I'll get rid of this a little. And now let's create our original number first. So final string original number as string, which will be the original number builder dot to string. And then we'll reverse it. So reverse number as string, and then we'll simply add reverse right here. And now we have the original number as string, the reverse number as string, and all we have to do is return original number as string if it equals the reverse number as string. Okay, let's run this program and see if it works. I had the test case programmed to 1, 2, 3, 4, 3, 2, 1, which is clearly a palindrome, and it says this is the correct answer. So let's try this on LeetCode and see how this behaves. So copying this code, going to LeetCode, and putting this right here. And let's run this code to see if it passes the base case for LeetCode, and it did. And now let's submit this and see how it performs. It actually performed pretty well. I didn't expect that. It's better than 87% of Java submissions, which is pretty nice. So now let's code the solution that we actually discussed. So let me remove this from here. So to keep things simple, we'll add our base case first, which is if the number is negative, which is if x is smaller than 0, then it's simple. It's false because negative numbers are not palindromes. Otherwise, let's create a backup of this integer first. So let's say int x backup equal to x. And we do this because we're going to modify the x value. Then we need another variable, which is x reverse, and we'll assign it as 0. And let's run a loop based on our brainstorming, which should run until x is not equal to 0. And in here, we'll first extract our last digit, which will be int last digit equal to x modulus by 10. And then we'll append this last digit to our x reverse. And for that, we decided we'll do x reverse times 10 and simply add this last digit. And then the third step was to divide x by 10. Now we have x backup, which is our original number. We have x reverse, which is the reverse. And now all we need to do is return x backup equal to x reverse. Let's run this program and see if this still works. It says correct answer, so this works. Let's copy this into LeetCode and see if it works there as well. So running this code, and I'll fix indentation in the meantime. Well, this was accepted for the base case. Let's submit this solution. And yes, this worked as well. And interestingly, its runtime is way higher than the string-based program. I'm pretty surprised here, to be honest. And in my experience, sometimes running the same program yields different runtime, and I'm not sure why that's the case. Anyhow, let's try to see if we can improve the solution further. So if this was going to be a shared code base with other engineers in a team, I would leave it like this because it's so much more readable. So if this is a program you need to actually check palindrome, I'll say use this. Otherwise, to reduce our runtime, let's see if we can make some optimizations. For instance, we don't need to initialize last digit as we use it only once when adding it to x reverse. So let's just copy this part and paste it right here and eliminate this last digit. Next would be the x is smaller than 0 condition, which is great for negative numbers. But if you remember in our brainstorming, we talked about another condition where a number, if it ends with 0, cannot be a palindrome unless it's the number 0. So for that, we can add a very simple test. So let's extract the last digit, which will be done by x mod 10, which you have done so many times by now. And if this is 0, then x needs to be 0 as well. And if it's not, then it's not a palindrome. So again, if the last digit of a number is 0, and if it's not 0, then it's not a palindrome. And this would improve our runtime because the program will return early if it encounters such a number. It doesn't have to go through the whole while loop and then figure out that it's not actually a palindrome. Well, let's see if this program still works. So running this program, we still get correct answer for our base case. Okay, so let's add the case that we have been talking about. Let's add 2 zeros to the end of this input, and our expected answer should be false now. And let's run this program. And don't worry about this code. This is just a simple code that uses our class to test any test cases that we have. And it says correct answer, which is expected. So let's use LeetCode to actually validate the solution. So copying this, going to LeetCode and replacing our existing solution and running this against the base. It succeeded. Now let's run it through all the test cases which LeetCode has. After running it 3 times, you can see the variation in the runtime. The first time it was 16 milliseconds, then 19, and then 9. So we know this is an optimal code. Maybe there's something going on behind the scenes in LeetCode server that slows down the program a little. Maybe I need to subscribe to their premium plan. Will that help? If you guys think so, then post it in the comments. But anyhow, our solution was better than almost 98% of all Java Online submissions for this problem. So hey, we have optimized our code, even though it took a few tries to actually see how well this program performs. Well, that was pretty easy. I hope you enjoyed solving this problem as much as I did, and we'll keep solving more and more problems. So if you like this video, don't forget to like and subscribe to my channel and to follow me on Twitter, and I'll be covering more questions soon. So keep an eye out for more videos. Thank you everyone.